Hi there guys, and welcome back to the shop. Today we get to do episode 6 on Project Archi, where we get to learn about this infernal little bastard. This is an encoder. Today's video is made possible through the support of Stephen Turan and dozens of other people just like you on Patreon. Check out the links below in the description to see how you can get involved and help support this, and check out the Discord to see how you can get personally involved. Thank you. Okay guys, so today it's all about the J1 motor. This is where we're going to start with our encoder stuff, and I've got a few things laid out. We've got the encoder itself. Here, I'll show you guys all this on the super sexy close-up cam. Let's get that there, because that's where we're going to be working mainly. But this is the actual encoder itself. This is specifically the AMT, that's Alpha Mike Tango 102 encoder. Now, the ones that I'm using are from CUI Incorporated. It's Charlie Uniform Ida. Now, there's a couple versions of this, and it's really important. You want to make sure that the one I got is the -V, the AMT 10-V-Victor series, that. And these are okay, but you're going to have a moment. That page in the instruction manual is very important because it shows the top cover, which is actually the whole encoder, and the base, which this is the one you want, and then the little happy dude. Yay! Okay, this is not the base you want, because if you try to put that base on your motor, nothing lines up. And I had a moment when I was setting up for this where I didn't see this. This had stayed like in the box, and I thought all I had was this, and I was like, fuck! So no, we're fine. This is, as long as you have this, you're cool. And it comes in the box in the -V. It's also going to come with a rainbow of fruit flavors of these. All the colors in my hand you don't need, for J1 at least. You'll probably need them for later on, but don't worry about it because every encoder comes with a whole set. What you will need is green. It's not easy being green. And you'll need the black one, which is different. All the other ones have like a little circle with a cross, like a star target reticle thing. This one's different. You'll need this. And you'll need this, which is a tool. And you'll need this, which is also a tool. Okay, so that's everything you need there. And you'll need that base, which does not have the little Happy Man arms. And you'll need a pair of very easy to lose and shoot across the room, and thank God I swept the floors this morning, screws. These are M3 by 5mm. And you're absolutely going to need 2 of them. They'll be in your hardware kit, assuming you bought the hardware kit. Maybe you didn't, but you know, if you didn't, you can get them at Fastenal or whatever. I trust you. I believe in you. All right, now this is my first encoder. I've never done this before. I did lay out all the parts, but I haven't actually assembled one of these yet because they like snap together and I didn't want to screw it up. So this is what you need to know. The first thing you do is you'll have a tool. It's got a fat end and a skinny end. For this one, we can use the skinny end. And that just goes over the shaft and lays down flat, all the way down flush to this face. Okay, so that goes all the way down. Then take the green thing. Now what these are is little shaft adapters between that exact diameter shaft and the outside, which is the same on all of them. And then this pushes down all the way down. All right, so now you grab the little black sleeve and we put that over there, and you use this tool. This is tool B in the instructions. Tool A is the little, not a wrench, but you use tool B to push this down and lock it into place. And you keep that under there, and what this is basically just a spacer. It makes sure that when you take it out, everything can turn and you're not locking stuff up. So this goes under like that, and you push it all down. This will engage. Now this is toothed, so you don't just ram this down. Turn it until it engages. And then push it down hard, and that'll seat it. And then you just slide this out clean, And now you're good, it works. And we can see that that'll turn and it's locked to the shaft. So this is a little cogged gear, and that is what sends the data from the motor to the thing. So we put this on here. Now this is the bottom piece, and you can see there's countersunk holes. And there's a million different holes in this thing for whatever motor you would want to put it on. We're going to use it just like that. And as we put it on, it says to use this to keep it centered. And yeah, I can work through that. You can't see it very well in that light, but I'll get better lights eventually. Don't worry about it. So then you take your little screws. These are M3 by 5 screws. And you're going to put one through each hole. Now I'm going to go get the Allen wrench it fits at, which I think is a 2mm. It is. So I have a lovely 2mm Allen wrench here. And we're going to drop that right down, backwards till it clicks, and then in. And we'll tighten that down. And then we take this out, and now this is totally mounted. So on your encoder, you'll see that there is a tiny little set of dip switches. One of them has to be not like the others. And you can see that right now, on is up. So if they're up, they're on. And so this is how it came. They're all off at this moment. And we want to turn number 4 on, just like that. So off, 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 on. 1, 2, and 3 are off, and 4 is on. And what that does is sets the programming in the encoder to a resolution of 512 steps per revolution, to a resolution of 512 steps per revolution, or 1024 PR for both channels. So that's what you want for there, because you need to set this to the right number of steps. What this does is sends pulses down here as this turns. And you need this to send the right number of pulses and the right type and the right order and all that, so that later on we're getting the data that we expect to have at the other end and everything works. So after that, flip it over, and then it just snaps down into place. Be gentle. This is rather delicate. So there's 3 snaps. There's one here, here, and here. We're now locked down, and we've got our motor leads here. So next we're going to add this set of wires here. Now this is one of the high-speed encoder cables. You should have brown, red, white, green, black with the connector up. Brown, red, white, green, black. So that's how it should look. And you just plug this in and it'll click like that. And you have now successfully connected an encoder and mounted it to a motor, and you made a thing, and you're awesome because you did a whole thing there. That's neat. So now we have the ability to know where this motor is, because a stepper motor works by sending pulses down these wires, and we can say, okay, move 1,000 pulses counterclockwise, and just bzzz, and it goes off like that. But sometimes, and for a lot of applications that's fine, but sometimes, like if the robot comes into contact with something, if the motor gets stalled out from too much of a load on this end or something like that, then you can send steps to the motor and the motor doesn't actually move. And this is a really big problem, because now the robot doesn't know where it is. By having the encoder on there, no matter what kind of forces act upon this or whatever, like if the robot in any way gets moved when instructions aren't being sent to the stepper motor to move the robot, if it just gets moved arbitrarily, the robot doesn't know where it is, you've lost mastering, and everything goes to hell. Because now the next time you tell the robot to do something, it's going to just move that number of steps regardless of what's in the way. And this can get expensive really fast, or just really suck with a little robot like this. By having the encoder on here, this allows us to, independently from the motor, as long as there's still a physical connection, no matter what the motor says or does, this encoder is going to know where the robot is. Because it's two totally independent systems. These wires tell the motor to move. These wires tell us where the motor moved. That's so cool. I gotta fidget with it. I gotta play with it. But now we got the encoder on there, so the next thing to do is to make this the right length and sexy. So I'm going to unplug it from here. By the way, to unplug these, this is an important thing to know. These plugs have a little terminal, a little dingus on top, a little plastic bit. And don't force this. This should just go in with just the lightest of fingertip pressure, and you'll feel it and hear it click into place. So to take it out, you press in the middle, right there, right exactly here. There's a center tab, and you just press that down, and that'll come right out. So you're set there. So this is it's about 20 inches long, 19.5. This is about 19.5 inches long encoder cable, and we're going to cut it right in half. So to find the halfway point is really easy. Take both ends, bring them together, hold them even like that, and just run your hand right down to there. That's our halfway point. And then we're just going to clip these right off. Like that. So now we have 2 encoder cables, and you will use the other one later. For right now, we're just going to put this one back on our motor, because that's our first one right there. And this is the actual encoder cable that we'll be using, and this is going to end up running like around and down and in later on. But the first thing we have to do is make it sexy. We can't have all this floppity wire stuff. That's not professional. So we're going to put it in some of this super sexy, this is ARchi3 PET braided sleeve. And we're going to cut off 9 inches of this right here. I can measure things on my mat. It's just easy that way. So we want 9 inches of that. That's 23 centimeters if you're into that kind of thing. Now, after cutting this, you want to melt the end just a little bit. Make sure to squeeze it open. And you melt the end a little bit, and that keeps it from fraying, because this stuff really likes to fray. And then we're going to take all of our wires and bundle them together, and then sleeve them inside this sleeve. And we're peeking out the end. So now that I'm at the end, it's really easy to slide that up. Like that. Cool, and there's our end. So see, that looks way better. Now when we run this down and around, like I think it's going to go through one of these holes down into there. And that's way more better. Okay, so now we snug this right up on there, and I'm going to put it, like this has a flatter axis where it came off spool. I'm going to put the flat axis to spread that way. And then I'm going to zip tie this up here nice and tight. You want to be careful and not put undue force on the things here. So you want to have this out like at least 1/2 inch from the plug. Because if you put this right up tight, you'll put a huge amount of force on the cables, like squeezing them together, and you don't want to do that. And then we'll trim that off, because we always flush cut our zip ties. And then I'm just going to leave this hanging like this. We'll do this end later, but this is going to get terminated and soldered up down inside the electrical enclosure when we're done. So that's all, this will end up in there. Yeah, this is cool. I am excited because we have a motor. It's wired up. It's good. It's cool. I'm curious to see how these get bundled up. I'll bet these end up in a sleeve or something later on too. But now we have a motor and encoder all ready to go. You have no idea how bad my desire is to just hook an Arduino up to this and just have this thing moving back and forth on the bench. And that's something that I may very well succumb to in a very near episode. We'll see how that goes. But for now, we have a J1 motor and encoder, and it's ready to go. So with that done, I have a correction to make. I have failed you. Something important to realize as we go through this process is I'm not a professional robot builder. This is the first one of these I've ever made. And I'm learning this as I go along. In a previous episode, 3, I think, I taught you all about how to cut and shape this bolt right here. I'll show you here. This bolt, the episode 3 bolt. And I did a pretty decent job of showing you how to cut it and shape it and make all that happen. I, however, did a really terrible job of teaching you where the hell the bolt goes because I put the damn thing in upside down. What? It's not an 8 or a 10? 8mm wrench? Oh, okay, it is an 8. Just you gotta use the other one. Okay. I did a really dumbass job of showing you where to put it. So if you put your bolt there, instead of, if you did it the way I told you, instead of the way the manual says, your bolt will be up here on top. Please remove your bolt from on top, reach gently under, and put your bolt in the bottom. Because I had somebody write into me and be like, hey, dumbass, guess what you did? So yeah, I put the bolt in the bottom. And you still have to align one of the flat slots tangent to the bolt circle. But that isn't hard to do. And hell, if I can do it, you can do it. Hey, that's the theme for the electronics series. Yeah, that'll do. Okay. And that bolt sticking out there is actually going to interface here on the back. It comes around and it'll boop, it'll touch a limit switch, but we'll get to that in the future. All right, so there's my correction. I had to do a little hat eating there. And we get to play with the limit switch in the next video. So we get to learn about the bolt and the limit switch and all that, and you can bet I address this correction again there too. You guys have fun. I want to thank you hanging out with me today, and we're making a robot, and it's cool, and I'm I'm excited. I am irrationally excited. No, I'm perfectly rationally excited about this. We're building a robot. We are wrought forth from the elemental materials of the planet itself. Like most of this is aluminum, which is pretty much space-age dirt. We're making a thing that will move and manipulate objects, and like this is epic. This is really cool, and I'm excited. So thank you for hanging out with me today and learning about encoders. You guys have fun. I'm Chris Boden. As always, we'll see you next time.